Okay, hi, so welcome to this video on enzymes and digestion. Alright, so in this video we're going to be talking about the main digestive enzymes that you need to know and the reactions in which they catalyze, okay? So, first of all though, digestive enzymes in general have one basic role, and that is to break down, large molecules into smaller molecules. Okay, that's a really basic overview, but we have in our bodies large storage molecules, right? Those include carbohydrates, they include proteins, they include fats, right? Or lipids to be more precise. Now those molecules are really large, but they are made up of smaller building blocks, and digestive enzymes are used to break down those into those small molecules, right? We also actually use enzymes the other way around to turn small molecules, put them together into larger molecules, but we're not going to look at those in this video, and you're not going to look at those in this course. Alright, so let's have a look at our first example, which are the carbohydrates. Okay, just a quick side note. Enzymes in general normally have pretty helpful names, as in their names normally tell you what they do. Now, they always end in ASE, right, unless we're talking about a specific chemical, and sometimes we have separate names for them. But in general, the groups of enzymes end in ASE, right, ACE. And what comes in front of it normally tells you what they do, right? And the carbohydrates, therefore, break down carbohydrates, okay? So carbohydrates, this is break down large carbohydrates into smaller ones. I'm going to put in brackets here, sugars, right? Because a carbohydrate, is made up of sugars. All right, now the main example you need to know is amylase. Right, now amylase, what that does is it breaks down starch into maltose. Right, maltose. Now, this may be confusing to you because you've always been told, or you've always learned, that starch is the storage molecule for glucose. So why is it broken down into maltose? Well, maltose is actually just two glucoses joined together, right? So you actually are breaking it down eventually into glucose, but maltose is the product when you break down starch initially. Also, you might be thinking, why is it called amylase? Why is it not called starchase? Well, starch is actually made up of two compounds called amylose and amylopectin, and so that's where that AMYL comes from. Anyway, that's what it does. You've got this large molecule starch which contains loads and loads of glucoses, and when you break it down you get a load of these small sugars called maltose, which are actually just two glucoses bound together. Right, now amylase is actually produced in three places in our digestive system, which you need to know. Those are the salivary glands, right? So actually in our saliva, carbohydrates can be broken down because we have amylase in there. Amylase is also produced in the pancreas, and it's also produced in the small intestine. Alright, and next we have our proteases. You can probably guess what they do. They break down proteins. Okay, so proteases break down proteins into, I was about to say carbohydrates there, into amino acids. Right, proteins are made up of small building blocks called amino acids. Right, when they're all joined together, we call that a protein. Now, proteins are made in three places as well. Okay, they are made in the stomach, they are made in the pancreas, and the small intestine. Okay, I'll just give you a quick summary as we did before. Proteins are turned into amino acids. Right, as an aside, one protease that you need to know is pepsin. Right, pepsin is an interesting one. It's only produced in the stomach. Yeah, it comes from the stomach. Now, the reason why it's different to the other proteases, or a lot of other proteases, is because the optimum pH is equal to pH 2. Right, so very, very acidic. You can easily guess why, because the stomach is very acidic because it produces stomach acid, which is actually hydrochloric acid. Whereas elsewhere, you do not have an acidic pH, and so that would actually denature other enzymes. So the other proteases will have a regular optimum pH of around about 7, whereas pepsin, as it's produced in the stomach and it needs to work in the stomach, has an optimum pH of pH 2, so it can put up with your acid. Alright, now lastly, we have the lipases. Right, now lipases, as the name suggests, lipases break down lipids. Now remember, lipids are solid fats and oils. Right, and they break down lipids into, and this is the one which sometimes gets people because it's broken down into more than one type of molecule. Right, lipids, excuse me, are broken down into glycerol and fatty acids. Okay, sometimes that's confusing for people. Basically, a lipid is made out of a molecule of glycerol, right? Let's say that's glycerol. And coming off of it, you have 3 normally fatty acids, right? So you've got glycerol, and these are fatty acids, right? Basically, all your lipase is going to do is come down and separate all those, right? It's going to separate those bonds, right? So instead, you have your glycerol and you have your fatty acids separated, and that is how a lipid is broken down. Okay, so basically, you have lipids are turned into glycerol plus fatty acids. Okay, and that is what lipases do. Now, lipases are only found in 2 places, right? They're not produced in the stomach and they're not produced in the salivary glands. Okay, instead, you only get them in the pancreas and the small intestine. All right, and that's about it. So as an overview, your digestive enzymes break down your large storage molecules into smaller molecules which are going to be used elsewhere. Right? Those molecules are going to be used for loads of different things. For example, maltose is obviously going to be turned into glucose or other sugars, okay, which can be used for energy, or some sugars have other uses as well. Your amino acids, when you break down proteins, your amino acids are normally going to be used to make new, different proteins, okay, which are useful for us in our cells. Okay, although sometimes we use those amino acids for energy as well, but most of it is going to be to make new proteins and for growth and repair. Right, like lipids being broken down into glycerol and fatty acids. Well, those fatty acids can then be used either for energy or they can be used for us to make new fats, like our own human fat, which is used for insulation and also used as an energy store as well. So I'm just going to stop there. I hope that made sense. If it didn't, then please feel free to send me a direct email using the link below, or pop a comment in the comment box and I'll be sure to get back to you. As usual, please do like and subscribe because it does help me out and you'll be notified when new videos become available. But thank you very much for watching and I look forward to seeing you in the next one.